All right, welcome to our lesson on our first lesson, our earthquake unit. It's called Forces in Earth's Crust. This is lesson 1 of chapter 4. If you're following along in your textbook with your notes, it's on page 102. So last chapter we were talking about plate tectonics and how Earth's crust is divided into plates, and the movement of these plates creates a lot of the land features that we see on the planet. And we also talked about how plates move in different ways. You can have plates that move together, and we call that a convergent boundary. So you can have two plates moving and pushing against one another in this direction, and we call that convergent. We have also two plates that are pulling apart, and we call that, I'm sure you're saying it to yourself right now, divergent. And then we have two plates that are sliding opposite one another, and we call that transform. And we talked a lot about what features form along each of these boundaries. Convergent boundaries, we can have subduction zones if there's oceanic and continental crust. We can also have mountain building if there are two continents that are colliding. Divergent boundaries we find most often in mid-ocean ridges, and we talked a lot about Iceland being a very interesting geologic location because the mid-ocean ridge runs right below that country. And then transform boundary, we talked about the San Andreas Fault being a great example of that movement, of side-by-side movement. So this chapter is all about how the movement of Earth's plates creates strong forces that actually slowly bend and fold rocks. And this slow bending and folding of rocks can cause them to break. And so this chapter is the forces that cause those rocks to break, which then, in the next lesson, we're going to talk about cause earthquakes. So we're going to start looking at something called stress. Now, stress is a force that acts on a rock that changes its shape or volume. Now, this picture right here is a good example of the San Andreas Fault in California. You could see this. I mean, just think about the enormous force it must take to bend and stretch that rock. And that's what you're getting here in this image. Force is measured per unit area. And as the stress increases, the force increases. And you can see that stress adds energy to the rock. And energy is stored in that rock until it breaks. And we talked a lot about this when we were talking about our convergent boundary beneath the Juan de Fuca plate and the North American plate, how that is stuck and that energy is stored in there right now. And then once that slips, once that break happens, it's going to release an enormous amount of energy and cause an earthquake. So let's talk about... There we go. The different types of stress. So right here I have 3 images that we're going to be working on for the next few minutes. And these images are kind of, you might at first look at them and say, oh, this one, these 2 arrows are moving together, so that must be convergent. And these 2 are sliding side by side, so that must be transform. And these 2 are pulling apart, and that must be divergent. Well, it's actually a really good way to approach this. These are the 3 types of boundaries, and there's different types of stress that occur at each one of these boundaries. So right here we're looking at 2 plates that are pulling apart in opposite directions. So you could say that this was a divergent boundary. Okay, and along this divergent boundary, the stress, the type of stress that is pulling those plates apart so that they're just being stretched and thinned out in the middle is called tension. Okay, so tension is the stress. And remember, stress is the force that's acting on the rock. Okay, for this one up here, okay, we're looking at a convergent boundary. Okay, so that is convergent. You can see those 2 arrows pushing that rock together, and it's causing this sort of folded effect right here that we saw in our last image. The type of stress, so the force here, is called compression. Okay, and then over here we have a transform. Okay, so this is a transform boundary. You see them sliding side by side. Well, the stress that's involved here is called shearing. Okay. So when you have a convergent boundary, the stress, the force that's causing that is called compression. When you have a divergent boundary, the stress is tension. And when you have a transform boundary, the stress is shearing. All right, so when you have enough stress on a rock, whether that stress is tension, pulling the rock apart, compression, squeezing it together, or shearing, sliding it past one another, enough stress can build up on a rock that a rock actually breaks. And this is what we see in this image here. And when we have a rock that is breaking, we call that a fault. Okay, and I know that this was a word that came up a few chapters ago, but a fault is when stress breaks the rock. Okay. Now, when we have compression, tension, and strike slip, and we have a break in the rock, okay, the blocks of rock on either side of the fault have very specific names and move in certain ways depending on what stress is applied. And so we have these two blocks of rock here, and this one is called the footwall. Okay, and this one is called the hanging wall. Now, there are a couple of ways you can sort of figure out which one is which. A footwall you can think of if you were just hanging around, you could rest your foot on it. Okay. Well, that one, it kind of looks like you're floating. That's a little... Let's put this foot on the ground. Okay, so if you wanted to, you could stand there and just rest your foot on it. Okay, that's a footwall. You could stand next to it and claim your spot and just put your foot up on it. If you were on this one, you could not stand there and put your foot on it, but you could, if you wanted to, hang from it. Okay, so you couldn't stand at the bottom of a hanging wall and rest your foot on it. It slopes away, whereas the footwall slopes towards you. Okay, those are just creative way to remember it. Also, knowing the faults and how they move helps remember them as well. But remember, the stress can break a rock, and when the rock breaks, that's called a fault. And the rocks on either side of the fault are either the hanging wall or the footwall. Okay, so let's go on next type of fault. So for the next few minutes, we're going to talk about the 3 different types of faults and how they relate to the types of stress. Now remember, stress is a force that can break a rock. When the rock gets broken, we have a fault. Okay, you can think of it again. Stress is either tension, compression, or shearing. Tension, compression, and shearing can break a rock, and when it breaks the rock, you have a fault. Okay, so we're going to start with, very simply, our normal fault. Okay, now we'll start with, well, what type of stress causes a normal fault? If a fault is a break in the rock, what type of stress causes that? Well, tension pulls the rock apart. Okay, so tension pulls the rock apart, and the hanging wall moves down below the footwall. And we're going to do a little activity in class tomorrow. You'll actually be showing how this works. But this is a great diagram right here. We have our footwall, we have our hanging wall. If this one is moving in this direction and this rock is being pulled in this direction, the hanging wall is going to slip down. Okay? Now this is the big takeaway. Normal faults occur along divergent boundaries. Now why? Why would that be? Well, ask yourself, a normal fault is when tension pulls rock apart. If tension pulls rock apart, that boundary is divergent. Divergent boundaries, 2 blocks are being pulled apart, and when you have that happen, a normal fault occurs. All right, so a reverse fault is the opposite of a normal fault. Okay, so in a normal fault, you had tension pulling rocks apart. In a reverse fault, the stress is called compression. Compression squeezes the rock together. When this happens, the hanging wall moves up over the footwall. You can see in this diagram, this footwall block's being pushed this way, the hanging wall is being pushed this way. Okay, so that's a compression, squeezing those rocks together. These occur along convergent boundaries, and you can just follow those arrows to know when those two blocks are coming together, that is a convergent boundary. Finally, we have our strike-slip faults. The stress that occurs to cause a break in the rock that is a strike-slip fault is called shearing. Shearing causes rocks to slide past one another. Rocks on either side of the fault move sideways, and there's very little up and down motion. So you see that there's no hanging wall and footwall along here. These form along transform boundaries. So we had... this has been a lot of information. Make sure you take a few moments to review your notes. We have a couple of labs and activities this week to help reinforce some of this. But just quick review. We have stress, which is a force that acts on rocks. The types of stress that we talked about today were tension, compression, and shearing. Tension pulls rocks apart. Compression pushes rocks together. And shearing causes rocks to slide past one another. Okay. If tension is pulling rocks apart, you can have a normal fault. If compression is squeezing rocks together, you can have a reverse fault. And if we have shearing causing rocks to slip past one another, you have a strike-slip fault. All of these faults are areas where energy is built up from that stress. And when you have a slip or you have a motion, you could potentially have an earthquake. So this is where all this fits into our earthquake unit. So thank you very much. I'll see you tomorrow.